In this video, I'll show you how to graph a linear function by creating a table of values. Let's graph the line with the equation y equals 3x minus 2. To construct the table of values, first choose some x values and then calculate the corresponding y values. You want to have at least 2 points, x and y, to graph the line correctly. Normally, we write the x values from the smallest to largest, but you don't need to have constant leaps between these values. You might choose 1, 3, 4, 9, or negative values like -10, -5, -4, and -1. For this example, I chose the following x values. Let's start with x equals -2. The equation becomes y equals 3 times -2 minus 2. Solving this gives y is equal to -8. So when x equals -2, y equals -8. We have our first point, -2, -8. Let's keep looking for points. This time, take x is equal to 0. The equation then becomes y equals 3 times 0 minus 2. Solving this gives y is equal to -2. So when x equals 0, y equals -2. So the second point is 0, -2. Choosing x equals 0 when graphing a line is interesting, since the y value you get is the y-intercept. The y-intercept, or initial value, is the point where the line intersects the y-axis. Here, the line intersects the y-axis at -2. We'll see this a little later. We could stop now, since creating a table of values with 2 points is the minimum amount to graph a line. However, having more points makes it easier to draw an accurate graph. So let's keep going. Take x equals 1. The equation becomes y equals 3 times 1 minus 2. We solve this equation and get y is equal to 1. When x is equal to 1, y is also 1. Our third point is 1, 1. Taking x equals 2 gives y is equal to 4. The next step is to place these points on the Cartesian plane. To choose an appropriate scale for our axes, we can analyze the table of values we made. The maximum x value is 2, and the minimum is -2. The maximum y value is 4, and the minimum is -8. Let's use this scale. You could have also chosen to use a different one. The important thing is to ensure that all the points in the table of values are covered and the leaps are constant. Now let's place the 4 points on the graph. We'll start with the point -2, -8. To place this point, start at the origin and slide 2 units to the left and 8 units downwards. Now we'll place the point 0, -2. Since the x value is 0, all we have to do is move down on the y by 2 units. Continue in the same way with the points 1, 1 and 2, 4. The only thing left to do now is to connect the points using a ruler. There. The line y equals 3x minus 2 is now graphed on the Cartesian plane. As you can see, the points are connected and the line extends beyond the first and last points. This is because the line actually continues through an infinite number of points. So it's important to extend it to cover the entire Cartesian plane. Also, look at the point 0, -2. The line intersects the y-axis at -2. Like I mentioned earlier, this point is the y-intercept. Be careful. If the connected points don't make a straight line, either you've made a calculation error or the points aren't placed correctly on the graph. Let's move on to another example. Graph the line for the equation y equals -1/2 x plus 4. Let's choose some x values. We'll start with x is equal to -2. Replacing x with -2 in the equation gives y equals -1/2 times -2 plus 4. Solving this gives y is equal to 5. The first point on the function is -2, 5. Let's take x is equal to 0 as the second x value. Replace x with 0 in the equation, gives y equals -1/2 times 0 plus 4. When we solve this equation, we get y is equal to 4. When x is 0, y is 4. The second point on the function is 0, 4. Do the same for the other chosen x values. When x equals 1, y is 7 over 2, or 3.5. When x is 2, y is 3. Now we can place these points on the Cartesian plane. When we connect them, we get a line that represents the function y equals -1/2 x plus 4. You can see that unlike the first example, this line is decreasing. This is normal since the rate of change of the line, or the coefficient in front of the x variable in the rule, is negative. It's -1/2. If the rate of change is negative, the line goes downwards. If it's positive, the line goes upwards. You can also see that the line intersects the y-axis at 4 since it passes through the point 0, 4. This means that the y-intercept is 4. Creating a table of values is one way to graph a linear function. If you want to learn another way, there's a video for that too.